Hi y'all, let me give a couple disclaimers before I get started. Make sure you check my work. Sometimes I make mistakes, so you check along with the answers you have and what you know, and also make sure your answers are in the form that Ms. Rader wants. Number 1 says to add or subtract and write the result in standard form. If we have a complex number, standard form is a plus bi. So this one's pretty straightforward. We're going to copy 3. We're going to distribute our negative, which is a -1, so we get plus 7 plus 6i. We're going to distribute this negative. It changes the sign of everything in the parentheses. At this point, it becomes combining like terms. I see 3 plus 7, which is 10, plus 1 is 11. 6i minus 2i is plus 4i, so 11 plus 4i. I'm done. Number 2 says to find the product and write the result in standard form. This is two binomials. This is very similar to some stuff I taught you in Algebra 1, except it deals with I think I taught you guys to FOIL, so that's what we're going to do. We're going to do our first term. -5 times 4 is -20. Our outer term, -5 times I, is -5i. Our inner term, 4i times 4, is 16i. And our last term is going to be 4i squared. Now we're going to clean it up. Bring down the -20. -5i plus 16i is 11i. And then keep in mind that I squared is -1. So this is going to be 4 times -1. So I have -20 plus 11i minus 4. I can combine my -20 and my -4, so I get -24 plus 11i. Number 3 says to divide and express the result in standard form. The deal with this one is we have a complex number in the denominator, and we can't have any radical, including the square root of -1 in the denominator, so we multiply by the conjugate, and the conjugate of the denominator, 3 plus 2i, is 3 minus 2i. But we can't just go multiplying by 3 minus 2i, so we have to multiply by 1. So that's 3 minus 2i over 3 minus 2i. What's important, you look at the denominator, you change the sign. Since this was 3 plus 2i, we make it 3 minus 2i, and we multiply by that over itself so that it becomes, so this is really 1, right? So we're not changing the value, we're just changing what it looks like. So really what we get here are we get these two binomials. We're multiplying these two things together, and we're multiplying these two things together. So we can write those together, or you can just do it from here. We're going to FOIL 8 times 3 is 24. 8 times -2i is -16i. -7i times 3 is -21i. And -7i times -2i is plus 14i squared. If you can go ahead and handle that I squared, you could do that without writing it that way. I'm just writing it to make sure you see it. Now, the reason we multiply by the conjugate, since we're multiplying 3 plus 2i and 3 minus 2i, our middle term, our outer and inner, are going to cancel. So that's going to make I go away in the denominator. That's why we do that. So we have 3 times 3 is 9. And then here's where the magic happens. 3 times -2i, that's -6i. 2i times 3, that's positive 6i. So that -6i, that positive 6i go away. And then I end up with -2i times positive 2i, which is -4i squared. Okay, now it's a matter of cleaning it up. I look at the numerator. I have 24. Then I do -16 minus 21. That's -37i. 14 times I squared. I squared is -1, so that's -14. I look at the bottom. 9 and then negative 4 times I squared, that's negative 4 times negative 1, which is going to be plus 4. That's the whole reason we do this, is to get that I to go away in the denominator. We cannot have a radical, and I is the square root of negative 1. We cannot have that in the denominator. So now we're still cleaning up. 21 minus 14 is 10, so 10 minus 37i, and then 9 plus 4 in the denominator is 13. Now I think since this says standard form, you need to split this up. 10 thirteenths minus 37 thirteenths I. I'm not sure. You need to check your notes if you need to go this far or if you can leave it like that. Number 4, we need to do what this says to do. We need to write our answer in standard form. So we have some radicals here we need to simplify. So I know I can write 12. I'm looking for a perfect square. So 4 divides 12, 4 times 3, and then I know there's a negative 1 there, right? So I'm going to do the same thing with negative 27. The perfect square that divides 27 is 9. It's 9 times 3. And I know I have times negative 1, right? So I look at this, I have my outside 4, then the square root of 4, that comes out, so times 2. The square root of negative 1 is I, so that comes out, and the 3 is stuck. It's not a perfect square, so the square root of 3 stays like that. The other one, my 5 is there. The square root of 9 is 3, so it comes out. I have the square root of negative 1, so I can bring I out. The square root of negative 1 is I. And then this 3 is also stuck, square root of 3. So I'm going to clean up a little bit. 8I root 3 plus 15I root 3. These are now like terms. Since they both have I root 3, I can combine them together. 8 plus 15 is 23. I root 3. Double check that that's how your answer needs to look. Number 5, we're going to square this binomial. The first thing I notice, this negative square root of a negative, so I is involved, and I also notice that 81 is a perfect square. So I'm going to clean this up just a little bit. It becomes negative 3 plus 9i squared. The way you square a binomial, if you'll remember, you write it and you multiply it by itself. You cannot distribute that exponent. This binomial squared, it means something times itself. Now this is basically a FOIL problem. Negative 3 times negative 3 is 9. Negative 3 times 9i minus 27i. I get another minus 27i. And here I get 81i squared. Clean it up. Combine your like terms. 81 times I squared is 81 times negative 1, which is minus 81. 9 minus 81 is negative 72 minus 54i. That's in standard form. Number 6 says to solve by the square root property. To use the square root property, you must isolate the squared term. Okay, we want the squared term to be all by itself. So we're going to subtract 2 from both sides and get 3x squared equals 675. Then we're going to divide both sides by 3, and we get x squared is 225. Once you've isolated the the squared term, then you're going to take the square root of both sides. The square root of x squared is x, and there are two numbers that you square and get 225. That's plus or minus 15. 15 squared is 225, negative 15 is 225. So don't forget that when you do the square root property, when you solve by the square root property, you get a positive answer and a negative answer. Number 7 says to solve by completing the square. when you complete the square, you want to get the x squared and the x term by itself. You want to move the constant over to the other side. So we're going to subtract 50 from both sides. We get x squared plus 10x. Leave yourself some space, and we move that to the other side, and it's negative 50. Now, the next thing you do, you're going to take b, which is the coefficient of your x term, and we want to do b over 2. So we do 10 over 2, which is 5, and then we want to square it. So we're going to square 5, and we get 25. So we're going to add 25, but you can't just add to one side. Whatever you do to one side, you have to do to the other. Okay? So you take that middle term, half it, square it, and add it to both sides. Now, this is going to be a perfect square now. This is now x plus 5 squared. If you were to factor that, it would be x plus 5 times x plus 5. So that's x plus 5 squared. Negative 50 plus 25 is negative 25. Now, we're going to take the square root of both sides. We have a squared term that's isolated. So we're going to take the square root of both sides, and we get x plus 5. Square root of x plus 5 squared is x plus 5. This is a perfect square, but it's negative, right? So it's going to have I involved. Don't forget, when you take the square root of both sides, you have to do the plus or minus. So plus or minus 5i. This is really two problems here. A couple of ways you can do it. At this point, we can just subtract 5 from both sides, and we can say x is negative 5 plus or minus 5i. That's really x is negative 5 plus 5i, and negative 5, or that should be or, negative 5 minus 5i. This just puts both answers in one single form. Number 8, we're throwing it all the way back to 8th grade, and we're going to solve this using the quadratic formula. So we need to know A, we need to know B, and we need to know C, right? You can sing along if you want. I don't think I'll sing right now, but x is the opposite of b, plus or minus the square root of b squared minus 4 times a times c, all over 2 times a, which is 3. Now we're going to clean it up. Minus 5 plus or minus square root of 25 minus 4 times 3 is 12 times 3 is 36, all over 2 times 3 is 6. So negative 5 plus or minus 25 minus 36 is negative 11 over 6. Not a whole lot I can do here, but I do see that I have a square root of a negative. So I can take my I out, and I get negative 5 plus or minus I root 11 over 6. Double check on the form that Ms. Rader wants you to leave that. Number 9 says to compute the discriminant and then determine the number and types of solution for this equation. First thing we need is standard form, so we need to set everything equal to 0. So I'm going to move my minus 6x over. I'm going to add 6x to both sides. I'm going to add 6 to both sides. I'm going to set it equal to 0. Now, your discriminant, I think it might use a D. I don't remember what the symbol or the abbreviation for discriminant is, but it's b squared minus 4ac. It's the thing that's inside the square root with the quadratic formula, under the radical with the quadratic formula. So b is 6, so 36, minus 4 times a, which is 3, times 6, which is c. This was 6 squared. I didn't write that. Okay, so this is b squared minus 4 times a times c. Now we're going to just work that out, a little bit of order of operations. 36 minus 12 times 6, I believe, is 72. Let me double check. It is. 36 minus 72 is negative 36. So this is the value of the discriminant. Now, to determine how many solutions that gives us, if that were under the radical, like it is with in the quadratic formula, right? This is the part that goes under the radical. We'd be taking the square root of a negative, right? So we have two solutions because we've got the 6 and the negative 6, but they're complex solutions because I is going to be involved, right? Because we have the square root of the negative. So if you have a negative discriminant equals 2 complex solutions, because I is going to be involved, and you can that radical or that number has 2 square roots. If your discriminant is 0, that means you're only going to have one solution. And if your discriminant is positive, that means you have 2 real solutions. That means that I is not going to be involved. So for this one, the discriminant is negative, so we have 2 complex solutions. Okay, this next one says to solve by the method of your choice. There's lots of ways to do this. Quadratic formula works for everything, so you could square this, 3x plus 9 times 3x plus 9, move this over, use quadratic formula. What I notice here is I have something squared equals 4. This square is isolated, right? It's all by itself, so I can use the square root method here. I'm going to take the square root of both sides, and I'm going to get 3x plus 9 equals plus or minus 2. Don't forget to do that plus or minus when you're using the square root property. So this is now two things I'm solving. So 3x plus 9 equals 2, or 3x plus 9 equals negative 2. So I'm going to solve these two. And I get my two solutions, negative 7/3 or negative 11/3. Number 11 also says to solve by the method of your choice. Again, quadratic formula would work here. I'm going to see if this factors. What I notice is that I've got a 7 and 3. Those are prime, so that would be easy to factor. And I also know that 7 times 3 is 21, which is pretty close to 20, so I'm thinking I can factor this and not have to go through the quadratic formula. So I'm going to try to factor. I know that I get 7x and x to get 7x squared. I need 21 because I want to get close to 20, so I'm going to put my 3 at the back and my 1 here. I know my signs have to be different, and my largest value has to be negative. So I'm going to make this negative so that I get a negative 21, and I'm going to make this positive, and then I'm going to check it. Always check. So my first 7x times x is 7x squared. Negative 21 plus 1 is negative 20. 1 times negative 3 is negative 3. So it works. Now I'm going to use my zero product property, which means I'm going to split this up. If I have a product that equals 0, that means one or both of these has to equal 0. So I'm going to set them each equal to 0. I'm going to solve. And I get my two solutions. 12 and 13 both say to factor and use the zero product principle. So 12 says 15x cubed plus 90x squared plus 120x equals 0. This is 3 terms. So I want to look and see what's common to all of these. X is common to all of these, and 15 goes into all of these. So I'm going to factor out a 15x. When I factor out 15x out of 15x cubed, I get x squared. Factor 15x out of 90x squared, and I get 6x. And 15x out of 120x is 8. Really, I'm just dividing, okay? Now I have a trinomial. It factors. X plus 4 and x plus 2, right? 4 times 2 is 8. 4x plus 2x is 6x. This is still equal to 0. Now I have three factors, 1, 2, 3. I'm going to set them each equal to 0. If the product is 0, then 1 or all of these has to equal 0. I get x is 0, or x is negative 4, or x is negative 2. Number 13, you cannot factor until everything is set equal to 0. So I'm going to take these two terms here and I'm going to subtract them and move them to the other side. So I get 3x cubed plus 2x squared. I'm going to subtract the 75x. I'm going to subtract the 50, and that sets it equal to 0. Now, a couple of things I noticed. There is not something common to all four terms. There is nothing that will go into all four of those. There's not a variable common, but there are four terms, so I can group. I'm going to group the first two and the last two. The first two, I can factor out an x squared, and I'm left with 3x plus 2. The second one, notice your middle term's negative. When your middle term's negative, you want to factor out a negative. I'm going to factor out a negative 25. The reason I want to do that, I want to change all the signs. I end up with 3x plus 2. When you factor out a negative, that's going to change all your signs. That also made these match. That makes me happy. Okay? So, remember factoring by grouping, you factor twice. Now I have a 3x plus 2 common to both. And then this one, I look and I see a difference of squares. That will factor again into x plus 5 and x minus 5. Now I can use the zero product principle. I've got three factors. When I multiply them, they equal 0. So either 3x plus 2 equals 0, or x plus 5 equals 0, or x minus 5 equals 0. So we solve. And we get our three answers. Okay, number 14 to me is the worst one on the whole review. This is this is one of the problems that aren't very fun to do. The issue is you have two radicals, so we've got to get rid of those. We've got to do that by squaring, and we can only get rid of one at a time. Okay, so the first thing we need to do is isolate one radical. It doesn't really matter which one. You're going to have to do it twice anyway. I'm going to add this to both sides so that when I isolate, what I'm isolating is this one. So I get the square root of 2x plus 3 equals 1 plus the square root of x plus 1. Okay, so I'm going to isolate. Then the next step would be to square both sides. So I'm going to square this side, and I'm going to square this side. So this one, the square root of a square, is going to leave me with the radicand, or what's inside. This right here, be careful. This is where you're going to mess up. This is a binomial squared. This is 1 plus the square root of x plus 1 times 1 plus the square root of x plus 1. Okay, so I'm going to try to do this without taking up 5 pages here. 1 times 1 is 1, right? And then I have the square root of x plus 1 plus the square root of x plus 1. That's going to be 2 times the square root of x plus 1. And then I've got the square root of x plus 1 times the square root of x plus 1. When I multiply square root times itself, I get the radicand, so I get x plus 1. I get what's inside. Okay, let's clean up a little bit. I see 1 plus 1, which is 2. I see an x, and I see 2 times the square root of x plus 1. Okay? So I did all of that. I got rid of one radical. Now I need to get rid of this one. So now I'm going to isolate again. Isolate that radical. So I'm going to subtract 2 from both sides. So 3 minus 2, I'm going to get 1. I'm going to subtract my x from both sides. So 2x minus x, I get x. So this is x plus 1 on this side equals 2 times the square root of x plus 1. Now, how do we want to handle this? I think at this point I'm going to square right now. We could divide both sides by 2, but that's going to make this kind of ugly. I think we're going to get the same thing either way. But I think it's going to be better to square right now. So I'm going to square this, and I'm going to square this. So x plus 1 squared, remember, is x plus 1 times x plus 1. So x times x is x squared. 1x plus 1x is 2x. And 1 times 1 is 1. Then over here I've got 2 squared, which is 4. And then the square root of x plus 1 times the square root of x plus 1 is x plus 1. Okay, I have run out of room, so I'm going to take this, I'm going to copy it on the next slide and finish. Alright, make sure I've copied that correctly. Now, we need to get everything to one side and put this in standard form. So x squared plus 2x plus 1 equals 4x plus 4. I'm going to subtract 4x from both sides, so I get minus 2x. I'm going to subtract 4 from both sides, so I get minus 3. I believe this will factor. What do we get? Minus 3 and plus 1. Is that right? Always check. X squared minus 3x plus x is minus 2x. Minus 3 plus 1 is minus 3. Now we have 2 factors to set equal to 0. We get x is 3 or x is negative 1. Now here's the kicker. We've done all that work and a couple of these might not work. So we need to make sure that all of these work in our original equation. So if we, let me see if I can get this over here without doing another page. If we do the square root of 2 times 3 plus 3 minus the square root of 3 plus 1. So what do we get? 6 plus 3 is 9 minus the square root of 4. That's 3 minus 2 equals 1. That one works, right? Then we're going to check negative 1. Square root of 2 times negative 1 plus 3 plus the square root of negative 1 plus 1. So we get the square root of, so that's the square root of 1 plus 0. 1 plus 0 is 1, is 1. They both work. So both of our answers are good. If they didn't work, we'd have to throw one of them out. Maybe both, but we do have both that work. Check this one with your key. Make sure I did it right. That's a lot of work for one problem. Make sure I didn't make any mistakes. Alright, 15 and 16 are similar to solving by the square root property. The only difference is we have the rational exponent. Okay, so it's got to be isolated just like before. And then the way you get rid of a rational exponent is you raise it to the reciprocal, because remember, a power to a power, you multiply the powers. How do we make this go away? How do we make it become 1? Well, we do that by raising it to the 2/3, because 3/2 times 2/3 is 1. But whatever we do to one side, we also have to do to the other, okay? So this cancels, this goes away, we're left with x plus 4. Now, 2/3, remember with rational exponent, the top is a power, the bottom is a root. So here we are taking the cube root of 216, because that's the bottom number, the denominator, and we're squaring it. So we get x plus 4 equals the cube root of 16 is 6, and we're going to square that. So x plus 4 equals 36, and we get x is 32. A cube root only has one cube, so this wouldn't be a plus or minus. This is just 6, so we only have one solution here. 16 is similar. The difference, though, is this is not isolated. We need to isolate this term. So we're going to add 25 to both sides. We're going to divide both sides by 5. Now that it's isolated, we can multiply both sides, not multiply, raise both sides to the 2/7 power. This is all going to cancel, and we're left with x. And here we get 5 to the 2/7. Now, I'm not sure how you need to leave this. I don't know if you need to write it as the 7th root of 5 squared, which is 25. I'm not sure. Check your key to see what form to leave that in. This may be your answer here. I don't know if it needs to be written in another way. I like 17. 17 is an introduction to a procedure that you're going to use in pre-calculus, you're going to use in calculus, a way to make things better by substituting, by making something that just makes it a little easier to deal with. Here I see, it's a trinomial, but I see this square root and then this x, and I notice that x is the square root of x squared. So I have a squared term and a regular term. So I'm going to let, and I don't know what you did in class, I'm going to let a be the square root of x. Okay, so a is the square root of x, which means a squared is x. And I'm going to substitute that into this trinomial. So I get a squared minus 10a plus 21. Now it looks a little normal. I can factor. This is pretty easy factoring. I think it's a minus 7 and a minus 3. Always check. A squared minus 7a minus 3a is minus 10a. Minus 7 times minus 3 is 21. Now I'm going to use my zero product property. A minus 7 equals 0. Or a minus 3 equals 0. A equals 7. Or a equals 3. But I don't want a. I need x. Okay, so a is the square root of x. So the square root of x is 7, or the square root of x is 3. Square both sides, and I get x is 49, or square both sides, x is 9. Don't forget to go back and do the x part. This is only part of it. You've got to resubstitute and find x, not a. All right, 18, 19, and 20. I taught you in Algebra 1, and I'm sure you remember all of that and that I taught it perfectly well and you never had any questions about it, right? Ha! Okay, so absolute value equations and inequality. First important thing to remember is to isolate the absolute value. You can't do anything until that absolute value is isolated. So we're going to divide both sides by 3, and we get the absolute value of x minus 3 is 6. Now, absolute value problems, I always think about a number line. What kind of numbers have an absolute value of 6? What can I put inside here and get an absolute value of 6? Well, that would be 6 and negative 6, right? So this inside the absolute value could be 6. If x minus 3 were 6, then the absolute value of that would be 6. Or it could be negative 6. Notice I didn't change anything inside here. I looked at this number, and to get an absolute value of 6, it had to be positive 6 or negative 6. Now I have two very straightforward things to solve, and I'm done. Now notice it said that it had to indicate if it had no solution. If you get the absolute value, if you isolate the absolute value, there's something in here, we don't know what it is, you isolate it and you get a negative, you can't take the absolute value of something and it be negative. So if you isolate the absolute value and it's negative, that would be no solution. Now the one you have on your review has a solution, but I wouldn't be surprised, make sure you're paying attention. If you isolate the absolute value and it's negative, that would be no solution. 19 is an absolute value inequality. Again, you want to isolate that absolute value. So I'm going to subtract 8 from both sides, and I get the absolute value of x minus 3 is less than or equal to 6. Use a number line to help you, okay? I know 6 and negative 6 are going to be my kickers, right? Where is the absolute value less than 6? What kind of numbers have a distance from 0 less than 6? Well, that's everything in between 6 and negative 6, right? Everything in here has an absolute value less than 6. So that means we take what's inside that absolute value and we set it between 6 and negative 6, because when we looked at what numbers had an absolute value of less than 6, it was between 6 and negative 6. We solve, we add 3 to all three parts. And we get that. I'm going to let you graph that, okay? You know how to graph that. Close circles on negative 3 and 9 and shade everything in between. Alright, last one. This is has an absolute value. It has a greater than or equal to. We're going to isolate, so we're going to subtract 2 from both sides. And we get that the absolute value of this expression right here is greater than or equal to 3. Think about a number line. Here's 3, here's negative 3. Where is the absolute value greater than 3? Well, the absolute value is on this side. I mean, all of these numbers have an absolute value greater than 3, and on this side. So this is an OR situation. You take what's on the inside, and you see that everything over here is less than or equal to negative 3, or everything over here is greater than or equal to positive 3. Now we're going to solve these two inequalities. Subtract 1 from both sides, I get negative 4. Now I'm going to multiply both sides by negative 2. Remember, when you multiply or divide both sides of an inequality by a negative, you reverse the inequality, and negative 2 times negative 4 is positive 8. Or, going to do the same thing over here. 3 minus 1 is 2. I'm going to multiply both sides by negative 2, so I'm going to reverse the inequality, and negative 2 times 2 is negative 4. So you can graph that. When you graph it, it will be an OR. It will be two rays going in opposite directions. So don't forget to do your number line.